Last one in the set. Is this in standard form? No, but it's really close. It's not in factored form, but these coefficients are out of order. We would like to put the highest exponent first and the next highest and then the next. And it just counts down from there, but there's only 3 terms. We have a quadratic term, a linear term, and a constant term, and we're going to put them in order. Now, as we do that, I want to point out something here. You could just go ahead and say, well, you know what, this x squared that's in the numerator, I'm going to bring it down. So negative 3/2 x squared. Totally okay, you can do that. And then you're going to have plus 5 over 7x and then plus 9. So that's what we're dealing with. That is standard form. So we're going to come over here on the side where it says standard form, and that's what we're going to write. So let's scooch this over to where you can see it right there. There we go. A little crooked, straightened up. There we go. Let's write it. Standard form, f of x equals negative 3 over 2x squared. 5 over 7x and 9. Leading coefficient is negative 3/2. Leading term would be negative 3/2 x squared. Just saying. Degree is 2. That means this guy is quadratic. Quadratic. We have a quadratic and we're going to have some end behavior. Let's go ahead and start our sentences. As x approaches negative infinity, y approaches something, don't know what. And then as x approaches positive infinity, as we go to the right, y approaches something, don't know what. And we're about to find out what that is. Let's graph. It means we have to get up. There it is. Won't you look at that? An upside down parabola. I could have told you that. Upside down parabola, there it is. And so, yeah, actually let me scooch this over, you can see more of it. There you can see the whole thing now, I hope. Zoom out a little bit. Okay, so the end behavior on this is as I go to the left, as x approaches negative infinity, the graph goes down. As we go to the right, the graph goes down. So y goes to negative infinity on the left and negative infinity on the right. Okay. Extrema, I only have one, and it is a maximum, and it is the absolute maximum. And it's right there. 0.238, 9085, that's it. That's the highest I get. That is the absolute maximum. There are no points higher than that one. It doesn't go up to infinity, so we have an absolute maximum. Oh, my head's kind of in the way. And that is at, what was it? 238, 0.238, 0.238, comma, 9085. And of course that's rounded. 9.085. There's that. All right, and then we have one y-intercept. And that y-intercept is a little bit harder to identify because this point's in the way. But can we just use a little common sense here? Based on the standard form, if x equals 0, that term's gone, and we're left with a 9. So 9. 0, 9. I mean, click it if you need to, but the y-intercept is 0, 9. It makes sense. It's this last term that's dangling around here. That's one of the shortcuts that we're going to use. So when you're in standard form, your constant, this is so important, when you're in standard form, your constant is your y-intercept. Just saying. Okay, x-intercepts, they're going to be somewhere and somewhere, but they better end in a 0. Somewhere and somewhere. Let's find out where they are. Negative 2.223, right? Negative 2.223, and positive 2.699. 2.699. Okay, one more thing. And I want to, not one more thing, you just heard me say it, but I think it's worth repeating. I do want you to notice that everywhere you see a constant at the end of your standard form, that is your y-intercept. Let me move my head so you can see. But that 9 that's dangling around right there, that 9 is your y-intercept. And it happened on the previous problem too. There you go.